Hello students, welcome back to my channel. So today we will be covering the CBSE Board Grade 10, the first chapter, that is real numbers. So this is the first video for real numbers. There will be many more videos that will be coming soon. So let us take a look what is real numbers. Okay, so let's learn it. Numbers. So what do you mean by numbers? So earlier you have already learned about numbers, different type of numbers like counting numbers. So counting numbers is that we call as a natural numbers, right? That we can count like 1, 2, 3, 4. So these are also called, the counting numbers are also called the natural numbers. Now if we include 0 in the natural number, then we will get whole numbers, right? That you already know that whole number is the natural numbers plus the 0. Now, if you include the negative part of the natural numbers, then that will be the integers. Okay. So that means 0, 1, 2, 3, 4 like this. And the negative part means minus 1, minus 2, minus 3. So on. That will come under the negative integers. Now, if we say 5 by 9, minus 3 by 1, 4 by 3, 1 by 5. So what are these type of numbers? So if you take a look in the numerator, we have 5, minus 3, 4, 1, right? So you can clearly see that these all are integers, means this also include the positive or the negative part of the number. Now if you take a look at the denominator, so denominator we can see that 9, 1, 3, 5, these are also integer. But one thing you need to remember, that in denominator you cannot have 0. Why? Because we know that dividing by 0 is undefined. So denominator cannot any, so you know about the fraction, right? In fraction, whenever we are talking, we can't divide any number by 0. In the numerator we can write 0. So but in denominator we cannot write 0. So that this type, if we take a ratio of integers and the non-zero integer, that means in the numerator as integer and in the denominator as non-zero integer, so these are called the rational numbers. This thing you have already learned in earlier classes, that rational number, that is in the form of p by q, right? Where q is the denominator part which is not equal to 0, and both. So if we say the definition of rational number, if p is any integer and q any non-zero integer, then p by q is a rational number. Now if p is any integer and q any non-zero integer, then p by q is a rational number, that we know. So 9 by 4, if we make it in the decimal form, then we will get 2.25, that is also a rational number. 11 by 3, that is equal to 3.666, which will keep on going, which will never end. That is also a rational number. So in class 9 you have learned about the recurring and non-recurring decimal numbers, right? So here, since 3.6 it keeps on going, so this is a recurring decimal number, right? So recurring and non-terminating, so it is not stopping. So these things already you know, that you have learned in class 9. So now, as I said, that 2.25, since it is after 2 decimal point, it is ending, so that's why it is a terminating number. And 3.666, this will be the non-terminating, and recurring means when the same digits are repeating, so then that's why it is recurring. So non-terminating recurring number. So decimal form of rational number is can be terminating or non-terminating and recurring. So normally whenever we have a non-terminating recurring number, so whichever number is recurring, we put a bar on top of it. So 3.666, we can represent it as 3.6 bar. Now 4.914 dot dot dot. So here we can see that 914 is repeating. So that's why we have to put the bar on in the entire 914 number. Okay. So this is also a non-terminating recurring number. Now let us first identify the rational numbers over here. So 0.048 bar. So you can see that on top of 8 there is a bar, right? So this is a non-terminating recurring number because here 8 is repeating. So earlier in class 9 also you have learned this. Whenever a number is non-terminating recurring number or terminating number, that will be classified as the rational number, right? So that's why it is a rational number. Now if we take look at the next example, that is 4.914. 914 we have a bar on top of it. So here this is 914 is repeating. So this is also non-terminating recurring number. So that's why it is a rational number. Now coming to the third one, 2.066. So here we can clearly see that there is no bar. So that means it is terminating. So if it is terminating, then obviously it will be the rational number. Okay, so terminating, that's why rational number. Now let us take a look at the fourth one. 0.0122547825 dot dot dot. So can you see any numbers repeating? So no, there is no number is repeating, right? We can't find any pattern over here. So this means this is non-terminating and non-recurring. So we know that whenever there is a number that is non-terminating and non-recurring, we call it irrational number, or that is not a rational number. I think you remember this, that these topics we have already covered in class 9. Now the next one is 3.1415926538 dot dot dot. Here also you can clearly see that there is no number. It is, first of all, it is non-terminating and there is no pattern of the number that is repeating. So that's why it is also non-recurring and non-terminating. So that's why it will be the irrational number or not a rational number. Now let's take a look at the next one. 2.6135302986 dot dot dot. Here also it is non-terminating and non-recurring. So that's why it is not a rational number. 1.903574155569 dot dot dot. This is also non-terminating and non-recurring. So that's why it is also not a rational number. Now next one, 270.253. So there is a bar on top of 253. So that means 253 is repeating. So this number is non-terminating but recurring. So whenever there is a number is non-terminating but recurring, that will be definitely a rational number. So this is going to be the rational number. Now, few more examples. Now, which type of numbers are there? So already we have seen that some numbers are not rational numbers. So this thing I think you know already. Whenever we have a number that are not a rational number, so those decimal numbers that are non-terminating and non-recurring, these type of numbers are called irrational numbers. So irrational numbers, what is the definition? Whenever there is a non-terminating and non-recurring numbers, those numbers are called the irrational numbers, right? So numbers whose decimal form is non-terminating and non-recurring are called irrational numbers. Now let's find square root of numbers that are not perfect squares, like root 2, root 3, root 5, root 6. If you find the square root of it, you will see that it will never end and you will not find any repeating digits. So that's why it is non-recurring and non-terminating. Similarly, root 3 also, it will be non-terminating and non-recurring. The same goes for root 5 and root 6. So these decimal numbers are non-terminating and non-recurring. So that's why any number which is not a perfect square, if we do the square root of it, then those numbers will always be irrational numbers. So the square root of numbers that are not perfect squares are irrational numbers. Now, what we learned, natural numbers, that is 1, 2, 3, 4, that is the counting numbers. Whole numbers means natural numbers plus the zero part of it, that is, if we include zero to the natural numbers, we will get the whole numbers. Then we learned about the integers, that is the negative part. If we include the negative part of the numbers with the whole numbers, then we will get the integers. Okay, so these type of numbers all comes under rational numbers. Now, if we take the integer by non-zero integer, that normally we call it as a fraction or decimal, that also will come under rational numbers. So, that type of numbers will be terminating. It can be terminating or it can be non-terminating but recurring. Okay. So, rational numbers are those numbers which are terminating or non-terminating, but that has to be recurring. Now, irrational numbers are non-terminating and non-recurring numbers. So, if we combine these rational numbers and irrational numbers, the total is called the real numbers. So, we can in turn say that real numbers can be categorized into two main parts, that is rational numbers and irrational numbers. Okay. So, in this chapter, we will be talking about the real numbers. So, where we will be covering the rational numbers as well as the irrational numbers as well. Now, let us take one example, 8 divided by 2. So, this is very easy. You all know 8 divided by 2 gives you quotient as 4 and remainder as 0. So, here 8 is the dividend, 2 is the divisor, 4 is the quotient and 0 is the remainder. So, this formula I think you all know that dividend is equal to divisor into quotient plus remainder. So 8 can be represented as 2 here is the divisor, into 4 is the quotient over here, plus remainder is 0, right? So we can represent any dividend in this formula, that is divisor into quotient plus remainder. Now let us take another example, 15 divided by 2. So if we divide 15 by 2, the quotient will be 7 and there will be 1 as the remainder. Now 15 can be represented as 15 equal to, now divisor 2 into quotient, that is 7, plus the remainder, that is 1. Okay. So if we consider the dividend as A, the divisor as B, quotient as Q, and the remainder as R, then we can write it as A equal to B into Q plus R. So for two given positive integers A and B, A is equal to BQ plus R. So this is the dividend equal to divisor into quotient plus remainder. So here, if you take a look, in the first case we got the remainder as 0, in the second case we got remainder as 1. So where A is equal to BQ plus R, where R can be the whatever be the value, so it should be 0 less than R, less than equal to R or less than B. So whenever, what that means that remainder should be always less than the divisor. It can be 0, it can be more than 0, but it should be always less than the divisor, because here B is the divisor, right? So for any two given positive integers A and B, A equal to BQ plus R, where 0 less than equal to R, less than B. So that means remainder should be always less than the divisor. It can be 0, but it should be always less than the divisor. So in this case, since divisor is 2, so that's why we got two remainder, different type of remainder. One is 0 and another one is 1. But we will never get 2 over here. So this is called the Euclid's division algorithm. So this is the Euclid's division algorithm, which states that for two given positive integers a and b, a equal to bq plus r, where 0 less than equal to r less than b. So for any two given positive integers a and b, there exist unique integers q and r satisfying this condition a equal to bq plus r, where 0 is less than equal to r less than b. Now let us solve one problem. Use Euclid's division algorithm to find the HCF of 135 and 225. So since 225 here is greater than 135, so we will consider 225 as dividend and 135 as divisor. Okay. So I hope this thing you have learned in your smaller classes, like you call it to find the HCF using the long division method. So Euclid's division algorithm is based on that. Okay. So 135 1. Now the remainder will be 90. So now if we apply Euclid's division algorithm, so we get dividend equal to divisor into quotient. This should be quotient, not quotient. Divisor into quotient plus remainder, not remainder, remainder. Okay. So 225 equal to 135, that is a divisor, into 1 plus 90. Now we have to consider the divisor 90 and divide it as 135. So whatever will be the remainder, that will now become the divisor, and whatever was earlier the divisor, that will now become the dividend. So now we need to divide 135 by 90. So 90 into 190, then the remainder will be 45. So again applying Euclid's division algorithm, we get 135 equal to 90 into 1 plus 45. Now again we have to repeat this process until and unless we get the remainder as 0. Okay. So now consider, so whatever be the remainder, that will now become the divisor. So now 45 will become the divisor, and earlier 90 was the divisor, so that will become the dividend now. So now dividend will be 90. So now 45 into 2, we know that is equal to 90, and there will be no remainder, that is 0 remainder, right? So now applying Euclid's division algorithm, we get 90 equal to 45 into 2 plus 0, right? So since remainder here we got 0, so now the divisor in this division is the required HCF of 225 and 135. So whenever we will get the remainder as 0, so that time whatever be the divisor, that will be considered as the HCF of the given number. So the HCF of 135 and 225 is equal to 45. Now let's take the next question. Use Euclid's division algorithm to find the HCF of 867 and 225. Okay, the same way we have to do. Since here 867 is greater than 255, so we will consider 255 as divisor and 867 as dividend. So we are going to divide 867 by 255. So 255 3 is a 765. So we will get the remainder as 102. So applying the Euclid's division algorithm, we will get dividend equal to divisor into quotient plus remainder. So 867 equal to 255 into 3 plus 102. So now this 102, that is the remainder, will become the divisor, and earlier divisor was 255, that will now become the dividend. So now let us divide it. So 102, that is 204, remainder will be 51. So now again applying Euclid's division algorithm, we will get 255 equal to 102 into 2 plus 51. So this process we will keep on doing until and unless we get the remainder as 0. So now what we need to consider? We will consider the 51, that is the remainder, now the divisor, and 102 as the dividend. So 51, 2s are 102. So now the remainder will be 0. Okay. So again, applying the Euclid's division algorithm, we will get 102 equal to 51 into 2 plus 0. So now, since remainder we got 0, so now the divisor in this division is the required HCF of 867 and 255. So the remainder, so 51 was the divisor, so that should be the HCF. So HCF of 867 and 255 will be 51 in this case. So that's all for today. I hope you understood this. If you have any doubt, you can always put that in the comment section. And if you like my video, please just hit the thumbs up button and please do share with your friends. And to get upcoming videos notification, you have to just subscribe for it. So for that, you just press the bell icon and you will be notified whenever there will be new videos that I'll be uploading. Okay, that's all for today. Thanks. Bye bye.